Recap the old factoring. Make sure you remember because you'll have to apply that today too.
That's a good question. What is it?
So let's say, oh my goodness.
If you teach all that,
Yes.
that much homework.
We can play some more.
Actually, let me make this a minus so it's mixed signs. Minus 5 plus 3x. Okay, if I asked you to factor this, Brady, if I asked you to factor this, remember there's some steps that we go through in our head before we factor. The first one is what? Can you take out a?
Oh, the perfect
Greatest common
square.
Greatest common factor, the GCF, right? Does this trinomial have a GCF?
No.
No. It doesn't share anything. So I move on to the next step. Okay? Do you recognize it being any kind of pattern? Remember the patterns we learned with the difference of two squares and a perfect square trinomial? No, because 2 is not a perfect square. It's a trinomial, it's 3 pieces, but 2 is not a perfect square, so that leaves that off right now. So my last option is, can I put it in the box?
What box?
The cross box.
Oh, we don't gotta fix the middle one.
You do.
I'll let Kevin.
What are my signs going to look like before I start? Mixed.
What? I thought I was minus
Oh
5.
yeah, because you got both. You got
Remember, it goes, what you start, and plus plus gives you plus plus, minus plus gives you minus minus, but then if the second sign is minus, they're mixed. Which means one positive, one negative, right? Right. All right, so first term goes in the first box. That's right, last term in last box. Multiply those two together and you get negative 10x squared. Good job. Give me one positive and one negative that multiplies to negative 10 but adds to positive 3. Negative 2 and positive 5. Do y'all see that? Because negative 2 plus 3 is, negative 2 plus 5 is positive 3. But when I multiply them, I get negative 10. That's what goes in my box. What multiplies to this, but adds to this. No, that's not new at all. This is a review, a recap.
The first two numbers always gonna be that.
Yep.
The last number.
No, the first and the last number multiplied together. You have to find what multiplies to that, but adds to what's in the middle.
Wait, what? You gotta multiply what?
All right, first
What I
term.
gotta add to, bro?
It's got to add the 3x. Positive 3x. The 3x is in the middle. That's what it's got to add to.
2 and 5 don't add 3x.
Negative 2x and 5x.
Oh, alright,
Because it's a mixed sign situation.
alright,
Okay?
alright.
Okay. GCF. 2x. Remember, it's the biggest thing you can divide both of them by. How about here? 5. How about here? 1 what?
Negative.
1x. The bottom one's negative because when you go across, they're both negative.
Yeah.
So it's negative and it's negative 1. So this factors as 2x plus 5
Where do you get the negative from?
if both of them are negative when you go across, then the factor's negative.
You lost
Okay, when we did the box,
it. Yeah.
the only way to get a negative factor is if both are negative when you go
Where
across.
do you get negative from? All I see is 2 and 5, 3 and 5. This box, how you get negative?
These are the two numbers we found right here. This is, look, the first one goes in the first box. The last one goes in the last box.
Oh, so I just gotta equal the middle one first.
Right.
Then times them two together.
And that's what goes in your last two boxes here.
Alright. how am I supposed to know which one goes in the first box?
First one goes in the first box, so 2x squared. Last one goes in the last box, so -5.
Oh, alright, I don't understand. Alright. It's confusing, bro.
This is what we did 2 tests ago.
This was gonna break my grade.
No, it's not. Let's do another one.
No, my grade is dead already.
Let's say I had 3x squared minus 8x. Nope. Nope, nope.
So I
Yeah.
gotta do the thing to like be divided by x to square.
Actually, let's make it 16 in the middle. I'm sorry. Okay, now. Say again.
Why don't we have to do b divided
Divide by
by 2
3.
squared?
That's when we're completing the square. That's a different process. This I'm just factoring. All right.
No.
Does it have a GCF?
No.
No. What are the signs going to look like?
Minus, minus.
Minus, minus. So I don't have to keep up with signs, okay? First term, first box. So what goes in the first box? 3x squared. Last term, last box, 5.
What I gotta do first?
First term, first box. Last term, last box. Multiply those two together. That's 15. Now tell me 2 things with the same sign that multiply to 15 but add to 16. 1 and 15. Does everybody agree? Why?
Did you know how many other numbers add to 16?
They don't.
That multiply to 15?
I think they're supposed to be negative 16.
Since they're both the same sign, you don't have to put the negative on them here. We'll just throw negative in the middle on both of them when we're done. All right, what's the GCF here? X. What's the GCF here?
3, 5.
5. Don't divide them. Find the biggest one you can divide both of them by. Across, GCF
3x. 3x.
and GCF.
1.
So remember both signs are minus. I have x minus 5, 3x minus 1. So coming back to you a little bit.
Hey, never left me.
Bryce, we spent so long on this. What are you talking about? We didn't do it. All right. That was our basic factoring. Okay. Then we talked about a couple of special patterns. Did you say wait? Or not the first thing. The next thing we talked about was some special patterns. One of them, and these are on your sheet. This is the first one. The difference of 2 squares. This is where if we have a minus in the middle and both numbers are perfect squares, okay, then I can factor it as the square root of the first minus the square root of the second, and then do the same thing with a plus. Y'all remember doing that?
Yeah.
No.
Oh.
I don't remember none of that. Why are you going back?
Because we're building on that today.
We don't need to build on nothing.
Today you're going to have to do this to do what we do today. That's why I'm reviewing it with you.
I don't understand.
3-day, please.
All right. Now, let me show you one more example. Because there could be a number in front. These are both perfect squares, so I can still do difference of 2 squares. So I get 2x minus 5, 2x plus 5.
Well, why is that?
It's a pattern. If you put it in the box, if you did 4x squared plus 0x minus 25, and you put that in the box and you did everything, this is what you would get. It's a shortcut.
We find it, see?
No, that was completing the square. That was something different.
So you can stop
We're
there.
just factoring right now.
I don't know. how
We'll
you
solve
split
later,
five.
not right now.
I don't know how you get.
Foiling would put you back where you started.
Thank you. That's all you had to say.
What?
She made it simple. I forgot you go all the way around. I forgot.
Okay. Long as you understand that. Okay. Then we talked about perfect square trinomials. This is where we made it a perfect square if it wasn't. So this is where we found a good C. But I want you to be able to recognize if it's a perfect square trinomial. There were a few things we checked for. Do you remember what they were? The second sign had to be positive. What else? What were you saying, Cheyenne? Is that what you were going to say? No. What about the ends? What's special about them?
You take them
No, what?
You're getting there. These have to be perfect squares.
And they can't be a coefficient on the first.
They're- Whenever we complete the square, but if we're just finding perfect square trinomial, it can.
So if there was like a 2 up there, we wouldn't have to divide the whole thing by 2.
No, not this time. Not whenever we're just factoring. Ask me again, Cheyenne. You sure?
What problems did we do where the end of that had equal 0?
When we solve, and we'll get to that. We'll get to solving. Right now, we're just... Yes, it's an extension of this. Yes, yes. All right, so if they're perfect squares and you take the square roots of the ends, if you put those together and double, you should get what's in the middle, right? If all that happens, in other words, I have a good C here, then to factor it, I do x, the first sign, 5 squared. This is what you just took a test on. Remember where you found the good C and then you wrote it like that?
No.
Bryce, you just did it.
You lost me so much. I don't even know what you're doing.
I'm factoring it, Bryce.
I don't know what that is.
It's writing it
No problem.
like this.
Alright.
It's number 2 on the sheet that I just gave you.
You telling me I gotta divide the first one by 2? Is that the one I gotta do? Divide the first one by 2 and then put parentheses and then x and then the number I got when I divided?
That was forming a perfect square trinomial. Right now we're just factoring it.
I don't know how to do that.
Let me show you another one.
Hey, don't take off of your office.
Is the second sign a plus?
Yeah.
Are the ends perfect squares? If you take the square roots of the ends, multiply and double them, do you get what's in the middle?
If I what?
What's the square root of this one?
6.
What's the square root of this one?
5.
If you multiply those two things together and double it, do you get what's in the middle?
No.
6 times 5 is 30.
Yeah. Why are you doubling it?
That's the pattern. That's what you have to recognize. So to factor it, I take the first sign, put it in the middle, and put a squared here. Okay?
That's all I gotta do.
For those patterns. Now remember, this is review. I am reviewing you on chapter 1. We're now in chapter 2.
Feels like we're moving so
You're gonna go
fast.
with not even numbers.
If it's not like that, that's where we put it in the box. That's what I just showed you first. Okay? All right, so listen, because I'm fixing to show you 2 more special patterns. Okay? So right now, what we have in our brain, some of us have in our brain, difference of 2 squares, yes? Perfect square trinomials,
Yes.
and boxing it,
No.
yes. Okay? I will help you at lunch, Bryce. Stay at lunch, I'll help you with the box.
Oh, no. I
Okay, so those are the 3 things from chapter 1 that I need you to remember as we go through this. What we're going to do today is we're going to build on that a little bit. All right, you ready? New stuff. I am going to show you some new patterns.
That's how much paper I have.
You've already had that many notes? First thing I want to show you is a sum or difference. Now remember, perfect squares can only be a difference of two squares. This can be a sum or difference of two cubes. Okay, now let me make you a list of cubes on the board, because remember I have the list of squares up here that you referenced for a long time. But since these are cubes, so I'm talking about 2 to the third, which is 2 times 2 times 2, which is 8. 3 to the third is 27. 4 to the third is 64. 5 to the third is 125. 6 to the third, 216. 7 to the third, 343. That's about as far as you'll need to recognize for right now.
I need to write that down.
Yes, you need to write that down.
No,
All right.
no way.
I'm not, I'll even pause.
That's why I have to do one thing, stop doing that.
Mhm.
And then go back to doing something.
All right, so what you have to recognize is you have to recognize your list of perfect cubes, right, Andrew?
What?
Remember with squares, it has to be a difference. Okay, it's got to be minus. Cubes can be plus or minus because you can take the cube root of a negative number. Okay, you can do a negative times a negative times a negative. All right, let's say I have x to the third plus 64. And actually, I'm going to move this over a little bit so I can show you under. You know, it's not that easy. But your x and your 4 are absolutely correct. All right, so looking at this, I recognize x to the third is a perfect cube. And 64 is a perfect cube because it's on this list. Do we all agree? So when you factor these, and this is just a pattern that you have to memorize. I don't know any other easy way to tell you to do it. All right? Do a little parenthesis and a big parenthesis.
What?
This is no longer a quadratic. This is now moved up to a polynomial, so it factors a little differently, okay?
Where are you getting the other numbers?
I'm fixing to show you. I'm going to show you how to do it. Fill in your signs first, okay? Your signs are going to go same,
Same.
change,
What you gonna do in the middle?
and plus. I'm going to fill in the blanks in just a second, but right now I just want you to put the
You're not
signs.
doing same, same, same.
No, same change plus for your signs. Okay? Same change plus. Same change plus. Whether it's a sum of two cubes or a difference of two cubes. This, by the way, is a sum of two cubes
You don't put another 2 pluses?
because it's because the middle sign is a plus. Ask me again, Bryce, what'd you say?
You want 2 pluses?
2 pluses.
Do addition thing?
What are you talking about?
Do addition, buddy, the right thing. On top of the bottom.
That's just telling you what I did. Same change plus. All right. The third one has to be a plus no matter what. Even if this is a minus here, the third one's a
The
plus.
second one's gotta be a minus.
If it's a sum of two cubes. If this was x cubed minus 64, then it would be minus plus plus.
All right, you go ahead.
Same change plus. All right. What times itself 3 times gives you x cubed?
What times itself? What times?
X.
Yeah.
What times itself 3 times gives you 64? 4.
4. Wait, what? 16.
4 times 4 is 16 times 4 is 64. Okay. This one is 2, 3, 4, 5, 6, and 7.
7 times 7, 21. 21 times 7.
7 times 7 is 49.
That was tricky.
All right. Take the first one, square it, and put it in the first spot.
Huh? The 2.
No, no, no.
What?
Take the first term, so x, and square it and put it in the first spot. X squared. I'm sorry, I didn't hear you.
Well, if you square the first one, how you gonna get x squared again? You just squared it.
What?
No, we
You
took the
just
first.
squared the first one.
I take this one and I square it and I put it here.
Oh, so you ain't squaring the first one.
The first one in the little parentheses.
But you ain't squared, because it'd just be x.
X squared.
No, it'd just be x, because you just squared the first one.
Okay.
I mean, that's what you just said.
I squared this one. If I
You
raise,
didn't square it, you just moved it and put a
a
square on
squared.
top.
Yes, yes, Bryce, yes. All right. Take this one. Square it. It goes in the last place.
So that'd be 2 squared.
No, 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 no. Square 4.
No, if you square 4, honey, it's gonna be 2. I promise.
Do you promise me, Bryce?
Square 4, square.
Square 4.
Well, no, square 4 is gonna be 16.
That's right.
I don't know why the hell.
So then we have to find the perfect.
So now, you're thinking square root. That's why.
Yeah, but see, that's what you just did, right?
I squared it, right?
You squared it. Now,
All right.
what about the other one?
Now you're missing one in the middle, right? So think about in the middle. Put them together. Just put the 2 original together. That's it. Same change plus, square the first, square the last, put them together in the middle.
So we're not gonna need.
We're
that
not
for
solving it now
So
I have
that's
a
it.
question.
for that pattern.
Oh my, you got multiple patterns. I forgot about multiple, all the rest of the patterns.
Well, this is 2. I told you 3. This is 2 of them, sum and difference of 2 cubes, but they follow the same pattern. Yeah,
The same way you just combine
the middle, the first and the last. Yep, the x and the 4. Listen.
Hey, but hold on.
Okay.
I want a serious question here to answer, all right? You just squared 4, right? You got 16.
Yes.
You squared 4.
Yes. And I got
You
16.
squared x.
Yes, and I got
You
x
didn't
squared.
square x, obviously. You just put a 2 on top. So
Same
that means you
thing.
moved the 4 the same way. It'd just be
If
4
you
squared.
want to write this like that, that's perfectly fine.
So that I could just put x for the first one.
Squared.
I don't need a square because I just squared it.
You do need a square.
That's how
Let
you
me
got
pause this.
16.
I'm going to change this one up. I'm going to make this x cubed minus. Now remember, with squareds, it can only be a minus in the middle, but with cubes, it can be a plus or a minus. Let's do x cubed minus 125. Okay? Let's set up the parentheses first. Little, big.
So minus plus.
Same change plus. Exactly. So minus, plus, plus. All right. Signs. Bryce, you got those signs?
Yeah, right here in my head.
What do you put in the first?
Hold
Exactly. See? See?
up, hold up.
Right. What times itself 3 times gives you x to the 3rd? What times itself 3 times gives you 125?
5.
First one in the first spot squared.
X or x squared.
Let's go with the x squared, Bryce.
Alright, we go with that. Whatever floats your boat.
Last one squared in the last spot. 5 squared,
25.
which is 25. What goes in the middle? Bryce, yes, 5x. Good job. This is how I do it whenever I think. It's easy to set up this first set of parentheses, right? The x and the 5. Square the first one for the first spot. Square the last one for the last spot.
And then just take those 2.
Yes, if you want to write it as 5 to the second power, I'll get it. So if you want to do x squared plus 5x plus 5 squared, then that's fine. Okay? One more. Let's see if you got it.
Come on now. This is the last problem for you.
This is the last one of these. Then I'm going to show you grouping and I'm done. We'll pick up the rest of them tomorrow. 8x cubed plus 343. Do you recognize that everybody's a perfect cube? Yes. 8 is on this list. Right, Caleb? 343 is on this list. Taylor, punch him when he goes to sleep, please.
So when we count on these problems, it's always gonna be like cube.
Yes, these will.
Always.
Well, remember, if you end up with a squared, so if it's like x squared minus 25, that's a different pattern because they're not cubes,
But
they're
you're gonna show us
squares.
that pattern.
This is what I showed you a minute ago. This is where you do x minus 5,
It's on the list as well.
x plus 5.
Well, you just do it like you did the other one.
This is number 1. You're going to have to, so you'll have this
Oh,
sheet.
so we're gonna have to,
And you'll decide which pattern it is, and then you'll follow it exactly.
Why don't we just do the same thing that we did last time, but wouldn't that be 2x?
Yes, 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 yes.
So we're just gonna group in tomorrow and do this for homework, this is
No.
as it is.
Oh, where'd you get the? I could be wrong.
All right, where'd I get what?
I have no idea.
All right, yeah. Little parenthesis, big parenthesis. Okay?
Just 2x plus 7x.
Do your signs first, though. Same, change, plus. So plus, minus, plus.
And then the first one 2x.
So y'all figured out that it was 2x because 2 times 2 times 2 is 8. And then x times x times x is x cubed, right? So 2x. How about here? 7. If you've got this list, you should be smooth sailing. Okay? Square the first one. Square the last one. What do you get in the middle, though? It's just a pattern. You just memorize the pattern. Not even memorize. You look at your sheet. It's on your sheet. Grouping. Here's how you recognize it. Grouping has 4 terms. When you see 4 terms, you think grouping. Okay? I call these slasher problems. Let's say, let me get one that's gonna.
Easy?
Yeah, that's gonna. Well.
Well, no.
I really want to get one. Okay, let's do this. Let's do x to the third plus 3x squared plus 16x. Is this going to do?
I thought we just need one more time.
Plus 48. All right, so here's what you do with these. If you understand GCF, this will be a piece of cake for you, okay? When you see 4 terms like this, slash it in the middle. Keep this second sign with these, okay? Now look at the first 2. What's the GCF of these 2? Bigger.
1.
X squared, right? If I take x squared out of both of them, what is left? X plus 3. Okay? Are you all with me on that? Okay. Look now at the second 2. We're going to keep this middle sign. Do the second 2 have a GCF? Yes. What is it? Bigger. 16. If I take a 16 out, what's left? I hope you notice something.
X plus 3, right?
The x plus 3, I hope that's what you notice as you go, wait. There are two x plus 3's. Do you see that?
Let's do 16x squared, and then x plus.
I'm
3
going to
squared.
take this one. If you divide each one by 16, and put it on the outside. If you take the x plus 3 out, you know how you took the x squared out and wrote it on the outside? I'm going to take the x plus 3 out, and I'm going to write what's left. That's factored by grouping.
What?
Don't move that, let me get that.
Oh, wait, what?
All right, let's go ahead. Don't move it, let me get it down.
Where'd you
Okay.
get that 16?
If the middle sign is negative, so I'm talking about this sign right here, okay? If the middle sign is negative, then you change the last sign when you factor or when you GCF. It's the GCF of those last two. I think this is the most intuitive form.
Just rerun the steps.
Okay, so we slashed it in half. We looked at this as its own problem. What's the GCF of x cubed and 3x squared? Biggest thing you can divide both of them by no remainder is x squared. When we took that
Just
out,
brought that down.
when we took that out of these two, what was left was x plus 3. We brought the middle sign down.
That's why I did it wrong.
Right, so you could see the two steps. Now this one, if you were asked to find the GCF of these two, it's 16.
X plus 3.
Because if you divide both of these by 16, what's left is x plus 3. Now, because they have this in common, I take it out one time and write what's left. You don't square it because what you're doing is you're essentially taking it out. So like if this was x squared times y plus 16y, you would just write the y once in front and write what's left, right? Because you pull out the GCF. That's essentially the same thing that I did. You just write it once. Grouping tends to be the easiest for students. Let's do one more. Let's do one where the middle sign is a minus. I'm hurrying. This is the last one. Let's do 27x cubed plus 45x squared minus 3x. By the way, if you can't take something out, you always put a 1 in front to take out. All right, so I see 4 terms. I automatically think, oh, let me slash it. This should be what you think. Think it, Caleb. Think it. Slash it before, yep. All right, look at the first two. GCF of 27x cubed and 45x squared. 9 what? 9x what? Squared. What's left? 3x and 5. You're absolutely right. All right. Keep the middle sign. Okay. And now look at these two. Do those have a GCF?
No.
No. So put a 1. And remember, if the middle sign is negative, change the last sign. So this becomes 3x plus 5. Notice that the two sets of parentheses are the same.
Now you gotta do another step.
So the last step is to write the same parentheses one time. You just write them one time when they're the same. If they're not the same, it does not factor.